Hi, I'm Misha Avrekh. I'm a software engineer at the New York Times, and today I'm going to walk through implementing and deploying a cloud function in the Go programming language. Here's our use case. We have two cloud buckets, bucket A and bucket B, and we have a compute engine instance where a cron job runs, let's say, once per day, and it copies a file from bucket A to bucket B. Simple enough. Here is a slightly different version of the same use case, which is the one that I'm going to talk about today, which is basically performing the same task with a cloud function. So in this case, I will implement an event listener cloud function that will listen for when a file is created in bucket A, and when that file is created, it will automatically copy it to bucket B. First of all, quick recap. I know this came up in other talks today. What is a cloud function? So cloud functions are, as I already mentioned, single-purpose functions attached to events emitted from your cloud infrastructure. So like in this case, we'll be listening for a specific event, a file being created in the bucket, and then when that event is emitted, the function will get triggered. Similarly, event-based functions can listen for other events, such as files being changed or deleted, or similarly, database records being created, changed, or deleted, such as Firebase database records. And also, there is another type of cloud functions, which are the HTTP triggered function, where you basically trigger a function by calling its URL. And also, you can talk about cloud functions as a platform. So in a second, I will walk through the code for this function. The Go code that exists for the cloud function that I will be deploying is really the only thing that I need to worry about to perform this particular task. So I don't need to worry about setting up the server or any of the other execution environment related tasks. I just write my code and deploy it. So with that in mind, let's walk through the function code. So here's my function. Like I said, it's waiting for this file to be created in bucket A. So this is the event that will trigger this function's execution. The first piece of code that I have here is a struct that describes that event. So the event ID, which is a unique ID for the event that will be emitted, the file name, the bucket name, the content type, and the time that was created, that the file was created. These are the parameters that I'll be using in my code, but there are a lot more parameters that you can potentially use that are emitted with an event and that you can use in your code at this link. Second, you need to define your environment. The environment, as we will see shortly, is defined when the cloud function is deployed. In order to bring your environment variables into your function's code, you need to define a struct to contain those environment variables. In my case, I will just use one variable, the name of the destination bucket, so that you can easily change it in case you need to copy a file not to bucket B, but somewhere else. But potentially you can use other environment variables, such as authentication parameters and many others. And finally, I have a struct to define the parameters for my destination file, which you will see in a second. So here is the main function of the main part of my cloud function, the so-called entry point function. So this is the function that gets executed when that event, the file creation event, is emitted in the cloud. This function takes two parameters. It takes the execution context for the cloud function and the event, which is pre-filled by the Google Cloud Platform. And this event is of the type that I described above, this struct. All right, and it returns an error if there is an error, the main function. So first we process our environment configuration, return an error if we fail, check if there is a destination, if the destination bucket was defined, because we need to know where the file will be copied to. Connect to the bucket. We create the client, again, error if failed. Read the metadata from context. So this is useful for logging. Some of the metadata that's contained in the execution context, such as the event ID or the event type that I will mention. The event type is basically what happens with the file. In this case, we're just listening for the file being created, but there are a couple other event types. Also useful to log as part of your function. And then the bucket name, the file name, and the time the file was created. These are all good to have in your logs. So once all of this is done, we can read our file from the source bucket. Let's take a look at how that's implemented. Here's our read function. It takes the same context as a parameter, just passed in from the main function. The client that was created in the main storage, Google Cloud Storage client that was created in the main function, we can reuse it here. Then the bucket name and the file name. And it returns a pointer to an array of bytes or an error if there is an error. So first we open a handle on the bucket and we open a new reader, an IO reader on that handle. Again, check for errors, return errors if we have to. Defer closing the reader until the function returns, and we read from the file. We read the contents of the file into our bytes array. Again, check for error and return the pointer if everything is okay. So that's our read function. Back to the main function, check for errors, failed to read, one of the possible errors here. If everything's okay, we go on to copy the file to destination. So this is where we use the destination file struct, also fairly simple, just the name of the file, the name of the destination bucket, and the content type. You want to make sure that when you write the file to the destination, it's created with the same content type as your source file, since you're just copying the file. And we store the file. Again, here's the function. It takes also the execution context. The same client can be reused. And the destination file struct, which contains all the parameters I just described. And finally, the file contents that you will be writing, which is a pointer to that bytes array. Check that we actually have something to write to the destination bucket. If the file contents are empty, then there's nothing to write. Return an error, and again open bucket handle. Open the bucket handle. Set up an object with the file name to write to. Open a new writer, IO writer on that object, set the content type, and write the file, check for errors. If we can't write, return an error, and finally close the IO writer, and again check for errors. If everything's okay, we do not return an error. And that is basically it. That is the body of our function, and we are ready to execute our use case and test it and deploy it. Before we deploy the function, I want to quickly talk about two things or two questions. First of all, as we saw in the original use case, we were not using a cloud function. I proposed using a cloud function to improve this use case. So quickly talk about why. And second, why use Go for this particular task. My apologies for my early spring allergies here. So let's to answer those questions, let's go back to our first use case, bucket A to bucket B, a compute engine instance, and the nightly cron job. One alternative to that first use case that would work, that would not involve a cloud function, would be to set up a Cloud Run container that would essentially do the same thing. It would be triggered by a cloud scheduler, and it would run JSUtil copy on a file from one place to the other. So sort of the same thing, smaller footprint than a full-fledged compute engine instance, but this would work. In this case, you have to execute, in both of these cases, you obviously have to execute your task whether or not that file that you're copying exists. So you would be saving on the cost of your entire operation if you only executed this task only when that file actually exists. So one of the benefits of using a cloud function is to save basically to save on the costs of your setup. And second, a cloud function is just easier to maintain than either a full compute engine instance or even a full Cloud Run container, because all you have to do is write and deploy your code. So let us actually try and deploy it and see what happens. So before you deploy Cloud Function, you need to do two things. One is you need to make sure that you either have your Go mod with all the dependencies specified in the same directory as your Cloud Function, or you need to have vendoring activated. You need to have your vendor folder with all of the dependency code in the same directory as the Cloud Function. And also, when you're deploying for the first time, you need to make sure that you have the Google Cloud Functions API and the Cloud Build APIs enabled. If you use the gcloud CLI command to deploy, it will be using Cloud Build under the covers, so both of these need to be enabled. So let us try and actually run the deploy. So here is my command. So quickly, while it's running, I'll mention a couple of parameters here that are useful to keep in mind. It will take a couple of minutes, sometimes longer. The trigger resource is the bucket that your function will listen to for the object creation event, so bucket A. The trigger event is the event that it's listening for. So Google Storage Object Finalize is when file creation is completed, either by way of a new file being created or in a version bucket when a new version of a file is created. But like I mentioned, a function can listen for other events as well. It is useful to explicitly specify your region. If you don't, your Cloud Function will go to the default region for your project, but that way it is possible to end up with multiple versions of the same function in different regions. So it's good to specify it explicitly. And then finally, this is how you specify the environment variables, the destination bucket you remember from the code. If you have more than one, you can do a comma-separated list of key value pairs for the environment variables. And of course, runtime Go. And we let it execute. So our function has deployed. You get some output explaining what got deployed and where. It's successfully deployed. It's active. Let us now go into the actual Google Cloud Functions platform and see what we have there. So here it is, the console, and here is our function. It has been deployed, the trigger, the runtime, the memory allocated, everything is specified here. Let's take a look at the function and the logs. So here's the most recent deploy of the function, and it got deployed. Now let's actually test it against an actual storage event. So let's go into storage. I already have my bucket A and bucket B defined, created here, and I tested earlier, so let's delete this file. Same here. So here we have our buckets, both empty, bucket A and bucket B. So now we can test, just upload a random file to bucket A. Files, here is a file. Here it is in bucket A. And here it is in bucket B. So our function worked. Let's just verify that by going back into the logs. And here we are. So it executed, function execution started. It logged the event. Remember that logging statement that I mentioned with the metadata and so on. Here it is, when the function was successfully executed, the bucket name, the file name, and so on. So everything's okay. So now we have our cloud function deployed and successfully executed, so we've got an improvement on our initial use case. We have a cloud function that's listening for a file that's been created and copies into another destination. Which brings me to the second question that I wanted to talk about: why use Go? So obviously, this is a pretty simple use case. You're just copying a file from one place to another. You can use gsutil for that purpose, and it will probably work just fine. What you get with Go is a few things, the advantages of using Go. One is the logging that you've seen. Go has pretty advanced logging capabilities built into it, which we have used, and that you would have to set up explicitly with something like a shell script. The other thing is, if this were just a slightly more complex case, if you weren't just copying a file from one place to the other, but let's say, or from one Google bucket to another, but let's say if you wanted to copy a file from a Google bucket to an AWS S3 bucket, or if you wanted to write your file as a blob type object into a database, or if you wanted to parse your file based on some database schema and write the contents of the file into a database. Go has APIs defined for all of these situations. You can write to an S3 bucket with the right permissions if you have the permissions set up. Same for the databases. So just by changing the code, you can the Go code, you can fairly easily accomplish those tasks if you had to change your use case to accommodate those scenarios. And finally, some pointers on good coding practices for Cloud Functions written in Go. With Cloud Functions in general, you need to keep in mind the possibility of cold starts. So if your function is not used for a while, it goes cold. It basically loses its execution environment and takes a few seconds to start up again. The cold restart time is actually shorter with Go than with other runtime environments, so that's another reason to use Go, but that is something to be aware of. It adds latency to your application if you get a cold start. Always make sure that your function returns. You may remember in my code I checked in the main function that all the returns were there. If it doesn't return, it can kill your entire execution environment, such as if you use an OS exit, you basically lose your execution environment and you get a cold start. Specifically for HTTP triggered functions, make sure that you set your headers before anything can get written back to the client. Incorrectly set headers can actually lead to security issues, so you want to make sure that headers are set even before anything gets returned, including errors that go back to the client. Delete all temporary files. Any and all temporary files that your Cloud Function might create can actually get written into memory, so it counts against your memory allocation. And if you get a memory overflow, your function will crash and you will get a cold start. This is all I have for today. Thank you for listening, and please let me know if you have any questions.